Okay, so that had like nothing to do with the video whatsoever. You know, it was just an idea that I had in my head, so it ended up being at the start of the video. Anyway, to fully understand this video, you'll need to have learnt the following. You'll need to have learnt truth tables and also binary addition. So I have videos on both of these. So just follow the links here. Or if you want to just come along for the ride, that's fine. You can do that too. So in this video, we will learn how the half adder logic circuit works. So the logic circuit of a half adder looks like this. It consists of an XOR gate and a AND gate. It has two inputs, A and B, and it has two outputs, sum S and carry C. So to simplify the half adder logic circuit, we use what is called a block diagram. So the block diagram also has two inputs, A and B, and it also has two outputs, sum S and carry C. So the block diagram is basically the equivalent of the logic circuit, as you can see. So basically it's just the circuitry of the logic circuit is inside this block here. However, because we are only interested in the inputs and outputs of the adder, we can just disregard the circuitry altogether. So the half adder is basically what we call a combinational logic circuit. So with there being just two inputs, A and B, there can only be 4 different combinations. So to find the 4 different combinations, we will use what we call a truth table. So for the first combination here, so what could the first combination be? It could be either 0 or 0. So A could be 0 or B could be 0. Or A could be 0 and B could be 1. Or A could be 1 and B could be 0. Or A could be 1 and B could be 1. So to find the sum column here, this one here now, so to find the first output of this half adder, so basically we would use what is called as binary addition. So this is column A and B down here. So this binary addition here is basically what's inside this logic circuit here. So this binary addition here is inside here. This is how it's calculated, and this is how you get the output. So your inputs are here. So it's calculated using this binary addition inside here, and then you get your output sum S and carry C. So when A is 0 and B is 0, okay, what do you think you're going to get? If you've watched my binary addition video, you would know that the answer is 0. So, and there's no carry bit, so that's carry is also 0. Okay, let's move on to the next one. When A is 0 and B is 1, what do you think you get? Yeah, you get 1. And again, there's no carry bit, so carry is 0. What's the next one? A is 1, B is 0, and the answer is 1. And again, there's no carry bit. So now for the last one, when A is 1 and B is 1, the sum equals, can you guess it? No, it's not 2. No. Now, really, if you said it was 2, then you should get back and watch my binary addition video. So the answer is actually 0. And then the difference here is that because it's 1, 1, we get a carry bit. So the carry is 1. So that's why it's called carry, because, you know, it's the carry bit. And then we'll just tag the 1 on the end, and that's it, basically. That's how the half adder works. So if you would like to know how to design and build a half adder logic circuit, click here.